Look at this image. A dense cluster of galaxies, thousands of them, packed together like jewels spilled across black velvet. This is the universe we're shown. This is the universe we're taught to admire, but it's a lie. Not a malicious one, just an accident of biology. Our eyes only detect light, so our attention is hijacked by anything that shines. Astronomers call it survivorship bias on a cosmic scale. We build entire mental models of the universe based on the tiny fraction of it that happens to glow. Here's the number that breaks that model. Roughly 80% of the volume of the universe is dark. Not dark like unexplored, dark like structurally, fundamentally empty. Vast tracts of space where galaxies simply never formed, where matter is thinner than anything we can recreate in a laboratory on Earth. So let's flip the map. The crowded, glittering regions we love to photograph, the galaxy clusters, the star-forming nurseries, the postcard universe, that's not the default. That's the exception. That's the crowded 20%. We live in the noisy part of town. Most of reality is silence. Welcome to the cosmic wilderness. To understand how strange this wilderness really is, we need to talk about scale, because these voids aren't just empty, they're empty on a level that breaks intuition.
Take the Boötes void. It's a roughly spherical region of space, about 330 million light-years across, containing almost nothing. A handful of scattered galaxies drift inside it, but for decades after its discovery, astronomers scanning it found almost total silence, as if someone had switched off a section of the sky. To feel that number, shrink the Milky Way, our galaxy, home to hundreds of billions of stars, down to the size of a single grain of sand. At that scale, the Boötes void becomes a hollow sphere, roughly the size of a football stadium, and inside that entire stadium, there's almost nothing else. No other grains of sand, just air. Our whole galaxy, reduced to a speck, would rattle around in there completely alone. And it gets stranger. There's a controversial but genuinely fascinating idea in cosmology called the KBC void, short for Keenan, Barger, and Cowie, the astronomers who proposed it. The theory suggests that the Milky Way itself might be sitting near the center of an enormous void, nearly 1 billion light-years across, one of the largest structures ever proposed in the observable universe. If that theory holds up, it means something almost uncomfortable. We're not typical. We might be living in a desert oasis, a slightly denser pocket surrounded by even greater emptiness than we assumed. The very fact that we exist to ask this question might be tied to the rare geography we happen to occupy. So the voids are big, but here's where the story stops being about size and starts being about secrets. Because voids aren't just empty space, they're time capsules.
Picture two neighborhoods. One is a dense galaxy cluster, a cosmic megacity. Galaxies collide, gas gets shredded and reheated to millions of degrees. Supernovae detonate again and again, spraying heavy elements like carbon, oxygen, and iron into the surrounding gas. Every collision recycles material that already existed, mixing it, cooking it, erasing its history. A galaxy cluster is polluted in the most literal sense. It's been through billions of years of violent industrial activity. Now picture the other neighborhood, a single void galaxy floating alone in the dark, with no neighbors close enough to interact with for over 10 billion years. This is why astronomers care about voids at all. Void galaxies are like isolated tribes that never encountered outside contact, untouched, unmixed, undisturbed. Because they haven't merged or collided with anything since the early universe, they remain chemically pristine. Their gas is still overwhelmingly hydrogen and helium, the raw ingredients cooked up in the first few minutes after the Big Bang, barely altered by starlight or supernovae. That makes void galaxies one of our only windows into what the universe actually looked like in its infancy. Every other galaxy has been through a nightclub full of collisions, contamination, and recycling. Void galaxies kept the original packaging. Studying them isn't just an oddity, it's one of the few honest ways we have to look backward at the raw materials the cosmos started with. Now let's talk about what voids actually do. Because it's tempting to picture them as passive, empty holes just sitting there while the interesting stuff happens elsewhere. That's wrong. Voids are active. They are, in a very real sense, engines. Think of the universe as a rising loaf of bread, or better, a pot of foam. As space expands, regions with less matter, the voids, expand faster than regions with more matter because gravity resists expansion and voids simply don't have enough mass to hold themselves back. So voids balloon outward, and as they do, they push everything around their edges, gas, galaxies, dark matter, into thinner and thinner walls and filaments. That's literally how the cosmic web was built. The web isn't glowing threads that formed on their own, it's matter getting swept to the boundaries of expanding bubbles of nothing. There's one void doing this on a scale that directly affects us. It's called the dipole repeller. It sits not too far from our own galactic neighborhood, and it appears to be pushing us away. But here's the twist. It's not pushing with some mysterious repulsive force. It's simply a region so empty, so lacking in mass, that the denser regions on the opposite side of us are pulling us toward them far more strongly. The result looks exactly like something shoving us from behind, when really it's an absence pulling everything else forward. Nothingness, disguised as force, quietly steering the motion of galaxies, including our own. Which brings us to the ending, the part of this story that stretches out past anything we can properly imagine. Fast forward, not millions, but trillions of years. The crowded galaxy clusters we started this video admiring, the busy cosmic cities, will burn through their fuel. Stars collide, merge, ignite, and eventually flame out for good. Gas gets used up, recycled one too many times, until there's nothing left to make new stars from. The bright, chaotic neighborhoods go dark. But the void galaxies, the quiet, isolated ones that never collided with anything, never got their gas stirred up or stripped away. They're still sipping from the same slow, untouched reservoir they've had since the beginning. They evolve gradually, conserving their fuel instead of burning through it in violent bursts. While the crowded universe races toward darkness, the voids barely change pace at all. So somewhere, unimaginably far in the future, when the last supercluster has gone black and the great cosmic cities have emptied out, there will still be a handful of stars quietly burning, alone, patient, and almost forgotten, out in what we once called the emptiest places in existence. The cosmic desert won't just survive the end of the crowded universe, it will outlast it. In the final chapter of everything, the last light in the universe won't come from where the party was, it'll come from the wilderness.